First thing that I'm going to do is I'm going to rewrite this guy as t times 9 minus t to the 1/2 power, because I'm going to need to take the derivative of that radical. And if I want to look at the idea of domain, and that's going to become important, the domain, t doesn't give me a problem, that radical does. The radicand must be greater than or equal to 0. 9 minus t must be greater than or equal to 0. Minus t is greater than or equal to minus 9, or t is less than or equal to, and that should be, yeah, that's a minus, 9. Get rid of that. I'll probably use these to scan him. So that means my number line is going to look like this. And it's going to start at 9 and move back. Why? Because that's what the domain of that problem is. So the only thing that makes any sense is a number line that starts at 9 and backwards. So here we go. This is product rule. So I'm off to find the critical numbers. F prime of t equals derivative of t is 1, derivative of the first, times the second, plus the first times. The derivative of the second is 1/2 times the blob to the negative 1/2 times the derivative of 9 minus t, which is negative 1. So clean this up. This is 9 minus t to the 1/2 plus 1, whoops, not plus. I just screwed up. What should that be? T 1/2 negative 1. So minus 1/2 t times t 9 minus t to the negative 1/2. And I'm going to take that, set that equal to 0. And in fact, let me get rid of this temporarily, be equal to 0. Let's simplify that derivative. What can I do?
Put 9 minus t to the 1/2 down.
No, I can't.
You factor out
Factor out a 9 minus t to the negative 1/2. This is a whole thing. So that means that I either have to factor it out, or I'm going to have to bring this guy down and put everybody over a common denominator, which would be unpleasant. So I'm factoring out a 9 minus t to the negative 1/2. This gives me a 9 minus t to the positive 1/2. I'm going to remove a negative 1/2. That's where this factoring worksheet's going to come into play. Minus 1/2 t, and I'm taking the 9 minus t to the negative 1/2. 9 minus t to the negative 1/2 times, that's a plus, so it's just 9 minus t minus 1/2 t. Nine minus t to the negative 1/2 times 9 minus 1t minus 1/2 t is 1.5 t, or 3/2 t. So now that's what f prime of t is. Now what do I want, other than to run screaming from the room? I want to know where f prime equals 0, and I'm going to divide my paper in half, or f prime does not exist. Now there's one thing I do need to do with this derivative. I need to move the 9 minus t to the negative 1/2 to the denominator. And that becomes a positive 1/2. So where f prime equals 0 is where the numerator is 0. So it's the 0 over some number. So that's where 9 minus 3/2 t equals 0. Or negative 3/2 t equals negative 9. Multiply both sides by the reciprocal, which would be a negative 2/3. This gives me that t equals 18 over 3, which is 6. So t equals 6. So I have a critical number of t equals 6. That's your potential max min right there. And by the way, what multiplicity is he? He's multiplicity 1 because he only appears once. That says he is a maximum or a minimum. Why? Because you know there's going to be a sign change across multiplicity 1 in f prime. Where f prime doesn't exist, because he has a denominator, is where 9 minus t to the 1/2 can't be 0. Square both sides. 9 minus t can't be 0, or 9 can't be t. Is 9 in the domain of the original function? What's the domain of this guy? T must be greater than or what? Equal to 9. So is 9 in the domain?
No.
Equal to 9. Is 9 in the domain? Yes. So that means he is also a critical number, because he is in the domain. So now I draw my number line. I need some space to work, so. And I put 6 on my number line. But my number line doesn't have an arrow on it. It's got a solid dot at what number? 9.
9.
At 9. And I know that 6 is multiplicity 1, so I have a change across 6. So now I just need to pick a number. My favorite number is available to me, and that's 0. So I look at f prime of t being equal to 9 minus 3/2 t over 9 minus t to the 1/2. So if t equals 0, I've got 9 in the numerator, and 9 minus 0 is 9, and I've got 9 to the 1/2 in the denominator. That sucker's positive. Change negative. Now you can, if you don't want to do it that way, then pull like 7 and put 7 in. Actually, what I would do, I'd pull 8, because 8 is even, and then that takes care of that fraction. Because that 2 will divide that 8 out. So that now says I have a increasing followed by decreasing. There's a max at 6. And nothing at 9. Because I don't have any way of getting across the other side. So he's increasing from x equal minus infinity to x equals 6, decreasing from x equals 6 to 9. And actually, that's not a square thing at 9. Because when you're increasing and decreasing, they're always open parentheses because it doesn't include the number. And I have a relative max at x equals 6.